So in this section, we're going to talk about Dot1Q trunking and go back over a little bit about what it does and why it is what it is. So it is the IEEE standard. So let me scoosh down here to Dot1Q trunking because it's a little more complicated to work with than ISL because there's more to it than just the what it is. So Dot1Q trunking, 802.1Q trunking, aka also known as Dot1Q. So IEEE standard. What it does is it inserts a 4-byte tag between the source and destination MAC address and the ether type field. What this basically means, and let me bring this guy up here to explain this. So this is basically the way it was setting up. So this is actually how our switches are configured right now. So we have ISL between all of the switches that can run ISL, and Dot1Q is running where it's supposed to. So everything going to switch 4 is running at Dot1Q. So now, if you look at it from this perspective, where you have Dot1Q, you have the source and destination MAC address. Then you have the length, and I'll type an E field. So the Dot1Q header goes right here. So as soon as the destination is known, where's it gonna go? Then the VLAN ID is tagged in there, and then that is how it's put across the trunk. So when information wants to go from here to here, the only time Dot1Q is used is from here to here. As soon as it jumps off into this switch, each port is able to have its own, like, I guess, let's say this is a port right here. I'll just put this. It's got all these funnels going off to all these different MAC address tables. So we have 10, 20, 30, 40, 50, and then we'll add 60 in here just for kicks. So we have 60. So no matter what the VLAN number is, as soon as it drops off on here, Dot1Q, it strips off the tag, and then the VLAN ID is known, so then it pushes it into VLAN 10. Or in our case, maybe VLAN 1 if we're going from switch 3 to switch 4. So it has all these VLANs, and it can just drop it off into whatever MAC address table, whatever spanning tree instance it needs to do it in. So that's how it drops it off. And then from there, the switch will put it in whatever, wherever it needs to go. So from there, that is how things are, that's how traffic is moved throughout the switches. That's how traffic is moved between switches, things like that. So the length and ether type field, if you've never heard of that, ether type is going to tell, going into the layer 3 header, what type of packet it is. Is it an IP packet? Is it an ARP packet? Is it an ICMP packet? Is it some sort of, is it maybe OSPF or EIGRP? These are all things that are going to come into play when you're talking about the upper layer protocols. That is why that when you look at the layer 2 information, so the data link layer, let's break this down. We have the MAC and we have the LLC. Actually, LLC. MAC address is the media access control. This is going to be your hardware address. Okay, this is your hardware address. This is what makes you specific to a layer 2 network. The LLC stands for logical link control. Logical should give you an indication that it's going to be IP. Now this is layer 2. What it's saying is the bottom half of the layer 2 address is going to be specific to the hardware and what's going to be doing with switching. As soon as the MAC address portion is peeled back, and then look at the LLC, which is what the ether type field would indicate. The LLC indicates what type of packet it's going to be. Is it IP, ARP, ICMP, is email? What is it? So typically at that point, TCP, UDP, that type of stuff. So then once this layer gets peeled back and they realize it's IP, then they can move it up to the upper layer protocols where this will be the layer 3, which is where IP exists. So it's going to tell it what type of, what the next layer or the next level is going to be. And in this case, it's going to be the layer 3 header, IP based. Now, if it's IS to IS, it's not going to do that. If it's MPLS, it's going to stop right here. Because it's going to say it's a layer 2.5 for MPLS, and it's going to peel back to the label value and say, oh, you're being label switched. Okay, it's going to look at the label forwarding information base and say, what am I going to do for layer 2 forwarding? It says that it's going to look at the MAC address table of the switch or the router, and it's going to determine, based on the CEF table and the LFIB, the label forwarding information base, what do I need to do with this? And then based on that, then it's going to forward it wherever it's got to go. So it says incoming label, say 17, is going to get, and then the next, what is it? The outer label is the transport. The inner label is the VPN tag. So it looks at the inner. The 17 is the outer. So this is the VPN tag. This guy gets peeled off, and a new outer label gets placed in put in its place, depending on what the inner one says. Whatever VPN. So this is the transport, and then they have the VPN tag. VPN tag is what the actual original payload is, and then that tag, or that label, I should say, maybe 21. So you look at 21 and say, okay, where are you getting routed out? So it says, okay, this maybe whatever the next interface is, and so then they put whatever the outgoing tag is. So this might get replaced with 18, and then 18 is placed in front of it, and so 18 is what's used from hop by hop. 21 in this case would be what the original label was. This isn't turning into an MPLS section, but that's kind of how it works with the inner and outer labels for the VPN and the transport tags. But that's how it works with logical link and MAC address. If you've never heard anybody explain that to you, that's basically how it works. So it rebuilds the trailer, the frame check sequence, to make sure that everything is the way it's supposed to be. The native VLAN support sent as normal untagged Ethernet frames. Anytime you see native VLAN, like in our case, VLAN 1 is the native VLAN. What that basically means is, as traffic from VLAN 1 leaves a switch, goes to a trunk, it is sent untagged. When it is sent, excuse me, and received on the other end, and as long as the native VLAN on that device is VLAN 1, it is still on VLAN 1. If the other device is configured for VLAN 10, then it will leave on VLAN 1 on switch 1, and then when it hits switch 2, and their native VLAN is 10, it'll actually be in VLAN 10. That is how VLAN hopping attacks occur. Or when you configure DTP and you negotiate a trunk, that is how things happen with VLAN hopping attacks. I've never actually seen one done, but that's the idea behind it. So what I'm going to do on all the devices is I'm going to go through and I'm going to configure everything to be Dot1Q. The reason for this is because of the fact of interoperability for new additions to the network in the future. Now, while DTP was chosen to be disabled to reduce layer 2 convergence time or in the event of trunk failure, modify the previously configured links to use Dot1Q as opposed to ISL and not to use DTP. I'll explain how this works. And then for between switch 1 and switch 2, so between here and here, let's see how far back I can take this. That's what I thought. Switch, open. We're going to use switch. Cancel. Or no, I'm already in here, so I don't have to worry about it. So between here and here, we're going to do, the native VLAN is going to be 6, or actually I'm going to use 777. So we're going to use 777 between these two devices, and I'll show you how that works. So, going from starting at switch 1, actually I was attached to switch 1 already, so bringing up the console cable one more time, and what we're going to do now, you know, it might have bugged out on me. So what I'm going to do, I'll close this guy out. And give me just a moment to get this situated. And what I'm going to do here is I'm going to go up here. I'm going to do show interface trunk. I'm going to do a show CDP neighbors. I'm going to figure out what port show CDP neighbors. And switch to 13. 13 and 13 on both sides. So what I'm going to do is I'm going to go to global config. I'm going to create VLAN 777. Because if you don't do this, I've had bad things happen where you get MAC flapping in between the devices. It's never good. So I'm going to exit out of here. I'm going to type in interface fast Ethernet 0/13. I'm going to type in switch port trunk native VLAN, and the native VLAN is going to be 777. I'm also going to type in switch port mode trunk, switch port trunk encapsulation .1Q. Hit the up arrow a couple times, bring that back over. It's going to drop it down. Now there's going to be a mismatch. So what I'm going to do is I'm going to pull up switch 2 just to show you guys how this works. This is all live. I'm not going to we'll come up here to global config. I'll type in VLAN 777. Type exit out of here. Interface fast Ethernet 0/13. Switch port trunk encapsulation .1Q. Switch port trunk native VLAN is going to be 777. Switch port mode trunk. Show interface trunk. And now we have it's Dot1Q is on, and the native VLAN is 777. Like I said, I've had bad things happen with not creating a VLAN prior to making the a native VLAN. Alright, so spanning tree is working between switch 1 and switch 3, or switch 1 and switch 2 I should say. So what I'm going to do now is I'm going to go to switch 1 now, and I'm going to put everything into Dot1Q. Then exit out of here, show interface trunk. So we have 16 and 23. So config T, interface range, fast Ethernet 0/16 and 23. I'm going to type in switch port trunk encap Dot1Q, switch port mode trunk. End out of here, and so now everybody's in Dot1Q, and let me jump over to switch 2 and do the same thing. The reason I do switch port show interface trunk is I want to know what's trunking. So now I know 21 and 23. Config T interface range fast 0/21 fast 23. Switch port trunk encap Dot1Q, switch port mode trunk. There they are. Go to switch 3 real quick and do the same thing. Show interface trunk 13, 17, and 20. Config T interface range fast 1/0/13 fast 1/0/17 and fast 1/0/20. Now why did I do a range command? Because of the fact that if I did 13 through 20, it would do 13, 14, 15, 16, 17, 18, 19, and 20. I don't want all those devices or all those interfaces all being trunking, so you just do this: switch port trunk encap Dot1Q, switch port mode trunk. Now everything is trunking. Let's ping 192.168.1.64, and we're gonna telnet over. Show interface trunk 13, 18, and 20, and I don't have to do anything because they're already in trunking. It wouldn't make a difference. Actually, let's show you here. Show run. We have, even though these interfaces are all in switch trunk mode, it wouldn't matter if I even tried to add in information like that. It wouldn't matter. So what I'm going to do now is I'm going to go to, what am I, that's what I wanted to do. 13, 18, and 20. So I'll go to config T, interface, range, fast, Ethernet 0/13, 18, and 20. This is an older iOS, older iOS version. And I'll type in switch port, no negotiate. That turns DTP off. Now if you notice, we do a show run now. Actually, let's just do a show run interface fast Ethernet 0/13, 18, and 20. So we have switch port no negotiate, DTP is off. So let me go over to switch 1 and switch 2 now. I'm going to do a debug DTP packet. So you should see DTP packets coming in. At least we should. Actually, let's do, and instead of doing that, we'll do all. I'm just curious to see what's coming through. Let's do show interface trunk. 16. So we're going to do a show interface fast Ethernet 0/16 switch port. And negotiation of trunking is on. Alright. Well, I was hoping to do a DTP debug, but do show DTP interface fast Ethernet 0/16. So basically what this says is the TOS trunk on trunk. So my guess is this is operationally, administratively, and negotiated is what this is. And then we have operational, administrative. So I don't know what the S and T is. Hang on one second for me. Alright, as you can see here, it says trunk operational status, administrative status, and negotiation status. And then you see the negotiation. So it says that in our case here, we have encapsulation, so type, and then we negotiated Dot1Q for all of them, and then this would be, this looks like our switch 2's or whatever this guy connects to. This looks like he would be what's the word I'm looking for, his MAC address. And then so yeah, that'd be yep, that would be the MAC address. And then we had hello timer is expiration is 3 seconds. So it looks like everything is working, enabled STP, and statistics, everything looks good. So that's what that is. I had to look that one up. I wasn't sure what that meant. I was assuming what that meant, but you never know, especially I like Scott Morris. He's a really funny guy. If you've never met him, Google Scott Morris. I think he's got his own BGP autonomous system number, to be honest with you. The guy's amazing. So, and then learning.cisco.com, or the Cisco Learning Network. I would definitely check that out if you have the opportunity. It's a lot of really good information. So that's what that information means. It's the trunk operational status, administrative negotiation, and the type. So that's that. So I was really hoping to show you guys a DTP output, but I guess that's not going to happen today. But when we did get the native VLAN working, so that works for me. So In the next video, we're going to talk about controlling things with the trunk allowed lists and what we're going to allow across our VLANs, things like that. I hope this has been informative for you. I'd like to thank you for viewing.